In this video, we're going to explain some topics of physics like force, work, power, energy, and others. First, we're going to start with force. Force can be defined as a push or a pull upon an object resulting from the object's interaction with another object. Forces only exist as a result of an interaction of two objects. We have the formula that it says the units, and the units of force are newtons. The m stands for mass and is on kilograms, and the a is for acceleration and is meters per second square. There are different types of forces, like the frictional force, the tension force, the normal, the resistance, and the applied force. We also have the gravitational force that acts on every object. We have this problem that says a man is using a rope is pulling a box that has a mass of 15 kilograms with a force of 100 newtons. The rope forms an angle of 30 degrees with the ground, and they ask us to calculate the net force. So we have the knowns that they give us, and for this type of problems is easier if we use a diagram like this, so we can see that the force is going that way and forms the angle, and since it forms an angle, it has to be decomposed into the Fy force and the Fx force. So to solve this problem, we first are going to calculate the weight that is represented with a W, and the formula is mass per gravity. So we know that the mass is 50 kilograms, and the gravity is a constant, so it will always be 9.8 meters per second. That gives us 147 newtons. And then we calculate the Fy because it's pulling the object. For this problem, the Fy and Fx calculates with the next formulas. The Fy is equal to F sine of the angle and this is equal to 100 newtons since it's the force, and sine of 30 degrees, that is the angle. That gives us 15 newtons. And in the case of the Fx, instead of using sine, it is used cosine, but in this problem we're not going to use Fx. Well, in the next step is to do the symmetry of Fy, and it will always be a 0. because it's not going upwards or downwards, so it's always a 0. So we put all the forces that act on the F and the y-axis. So we have the net force, that is the one that we're looking for, and the weight. So we put N for the net force, and since the weight is going downwards, is pulling the object downwards, it's going to be subtracted, so it will be minus the weight and plus Fy. This is equal to 0. Then we replace values. Minus 147 newtons plus 15 newtons. And since we only want just the net force, we change all of the values to the other side and change the signs. So we end up with 147 newtons minus 15 newtons. And this gives us there as a result that the net force is 97 newtons. Now for work, power, and energy. The amount of work done by forces. When a force acts up on an object to cause a displacement of the object, it is said that work was done upon the object. In order for a force to qualify as having done work on an object, there must be a displacement, and the force must cause the displacement. We have that the unit of work is joule, and it is represented with a J. And here we have the formula. And this formula is used when we have an angle, like the other problem that had an angle. And the problem says, calculate the total amount done by the object of 15 kilograms sliding a distance of 10 meters through a surface having 100 newtons of force that forms an angle of 35 degrees and a friction coefficient of 0.5. So we have the knowns here and we have the diagram. So as the other problem, first we're gonna start with the weight. That is the easier to get. That is, weight is equal to mass per gravity. So is 15 kilograms times 9.8 meters per second, and that gives us 147 newtons. And since there are no other forces acting on the object, the net force is equal to the weight. So we will have that the net force, we'll take it as an equal to the weight, that is 147 newtons. Then in order to get the friction, we'll have to use the friction formula, that is friction is equal to mk, that is the coefficient of that gives us, that is 0.5, times newtons, I mean the net force, sorry, and this is equal to 0.5 times 147 newtons, and this is 73.5 newtons. So we have the friction here. And they are asking us to get the total work done. I mean, all the work done by all of the forces. So first we're gonna use get the work done by the force, like the normal force, that is 100 newtons. Newtons times 10, because the formula of work is force times distance, and when we have an angle that we had in here, it is multiplied by cosine of the angle, that is 35 degrees. This gives us 819.15 joules. Then, for the work of friction, we are going to multiply it by 73.5 newtons, that is the friction, then by the distance, that is 10 meters, and times the cosine of the angle, that is 35, and that gives us minus 35 joules. Now that we have these answers, we just have to add them. So we have the total work that the forces did. So is 819.15 joules minus 735 joules, and that gives us 84.15 joules. That is our final answer for the total work. Now for the power. Power is the rate at which work is done. It is the work divided by time ratio. The standard metric unit of power is the watt. So we have the formula here, that is represented by P, work by W, and time by T. This problem says the Taipei 101 in Taiwan is 67 foot tall, 101-story skyscraper. The skyscraper is the home of the world's fastest elevator. The elevators transport visitors from the ground floor to the observation deck on the 89th floor at speeds up to 16.8 meters per second. Determine the power delivered by the motor to lift the 10 passengers at this speed. the combined mass of the passengers in the cabin is 1215 kilograms. So we have the knowns that are the speed and the mass. And since we don't have all the data we need to calculate, the force we are going to take is the gravity, that is 9.8 meters per second. And so we are gonna take that force like it's pulling them downwards, that is the weight. So we are gonna assume that is the same force that is pull them upwards that the elevator does. So we have the weight, that is mass per gravity, and we have that the mass is 1215 kilograms times 9.8. 9.8 meters per second. That is 12,250 newtons. So that will be the force that we're going to take. So force is 12,250 newtons. Then, since we don't have another known, we are going to break down the formula. And the formula of power, that is power is equal to work divided by time. So we know that the formula of work is force per distance. So it will be force times distance over time. And we know that distance over time equals speed. So this means that power is equal to force times speed that we do have. So now we can replace the values to get to the answer. So it will be P equals the force, that is 12,250 newtons, times the speed, that is 16.8 meters per second. And that will gives us to the result, that is 205.044, that it can be converted with the exponent, that is 2.06 times 10 to the 5 watts. And that will be our final answer. Then we have energy. The concept of energy is related with the capacity of producing movement. There are three types of energy: potential energy, kinetic energy, and mechanical energy. as power, the unit of energy is joule, and we have the different formulas for each of the types of the energy. So first one is the potential energy, that is mass per gravity per height. This is in kilograms, meters per second, and meters. The kinetic energy, that is 0.5 times m times v square. The v stands for velocity, that is meters per second. And finally we have the total mechanical energy, that is only adding these two types of energy. We have this problem that says Olive Udari is at the park with her father. The 26 kilogram Olive is on a swing following the path as shown. This picture shows the path that the girl did. Olive has a speed of 0 meters per second at the position A, this position, and is a height of 3 meters above the ground. At the position B, Olive is 1.2 meters above the ground. At position C, 2.2, and Olive projects from the sea and travels as a projectile along the path shown. At the F point, Olive is a mere kilometer above the ground. So we have this table that we have to fill in. We have the values that they gave us. That is only the height and the speed at the position A. First, we are going to use the formula for the potential energy, because it's with these values is the only one that we can get. So it's potential energy equals mass per gravity per height. This is 26 kilograms times 9.8 meters per second and 3 meters. We multiply that and we have as a result 764.4 joules. With this we can start filling up the chart. We put the value here, that is 764.4 joules, and that the total mechanical energy, since the speed that has at that position is 0, so 0 by all of the variables that has the formula of kinetic energy will be 0. So this is 0, and the total mechanical energy sums of these two variables, so it will be the same, 64.4 joules. And this is always the same, so all the mechanical energy is 764.4 joules. Then to get the position B, we're gonna use the same formula, 26 26 kilograms times 9.8 meters per second times 1.2 meters. That is the height that she was in that position. That gives us 305.76 joules. This is for position A, and this is for position B. Then we can just fill in the chart, and since the formula of total mechanical energy is just the adding of these two, for getting the kinetic energy we can just subtract 764.4 minus 305.76 and we'll get the kinetic energy. And we have that the kinetic energy is 458.64 joules. We fill in the chart. With this, with the kinetic energy, now we can get the speed that is missing here. So we have to use the formula of the kinetic energy, that is kinetic energy is equal to 0.5 times mass times velocity square. So we are just going to replace the values so that we can calculate it. The kinetic energy is 458.64 joules equals to 0.5 the mass, that is 26 kilograms, and V square. We just will have to pass these values to the other side, and it will be first we're gonna multiply it so it can be easier. And we have that 0.5 times 26 equals to 13. And then we'll pass the 13 dividing, so it will be 458 0.64 divided by 13, and that will give us 35.28. But we have that this is a square, so we have to do the square root of 35.28. That is 5.9 meters per second. This is the speed at the position B. Now to the position C, we basically will do the same thing. We're gonna use the potential energy first. (26 kilograms times 9.8 meters per second times 2.2 meters. That is the height, and this equals to 560.56 joules. So then we use we get the kinetic energy by subtracting it. 764.4 minus 515.6 joules. That gives us 203.84 joules. Now to get the speed, we will do the same that we did here. That it will be replacing the values. The kinetic energy is 203.84 joules equals to 0.5 times 26 kilograms times b squared. So we multiply this, that it will be 13. We divide this just like we did here. Divide 203.84 divided by 13, and then we get the square root, and we will get that V equals to 3.9 meters per second. So we look here, 3.9 meters per second, and here 160.56 joules, and 203.8 joules. And finally, for the F position, we get PE for potential energy equals to 26 kilograms, 9.8 meters per second, and this is 0, so this all will equal 0. So since here is 0, here will be the 764.4 joules, and the speed, we have to get the speed by replacing the values. Equals to 13 times b squared. Then we divide 764.4 joules over 13, and then we get the square root, and this, so the result of this is 7.6 meters per second. So we have the speed. Next is the topic of temperature and heat. Temperature is a measure of the average kinetic energy of the particles in a sample of matter, expressed in terms of units or degrees designated on a standard scale. We have the scale here, and we have the Kelvin scale, Celsius scale, and the Fahrenheit scale. And we have these formulas that will help us to get to every scale having any type of unit. And heat can be defined as the transfer of energy from a higher temperature object to a lower temperature object. We have the equation for heat. Q stands for heat, M for mass, C is for specific heat, and delta T, that is the difference of T final and T initial. So we have a problem where it asks us to get the specific heat of the metal, and they gives us these variables, that is the mass of the metal, that is 12.9 grams, the initial temperature of the metal, that is 26.5 degrees, and the delta T of the metal, that is 60.6 degrees, the mass of the water, that is 50 grams, the initial temperature of the water, the final temperature of the water, and the specific heat of the water. So since we don't have much of information, in order to get the C of the metal, we are going to have to equal the heat of the water and the heat of the metal. Then we are going to decompose the equation. So replacing the values with the formula, that is m of the water, the mass of the water, times the specific heat of the water times delta T, that is this little triangle here, of the water. This is equal to the mass of the metal times the specific heat of the metal times delta T of the metal. We are going to clear this formula, so we can just leave the C metal alone so that we can get to the answer. So it will end up to be C metal equals to mass of the water times C times delta T, the temperature of the water and this will be divided by mass of the metal times T delta T Then we just replace all of the values and continue with the formula. Then we multiply all the numbers in the two sides. Then it gives us 313 joules over grams per C. And 781.74. We divide these two numbers to get the answer, that is 0.40 joules over G times C as our final result. The Ohm's law uses a formula used to calculate the relationship between voltage, current, and resistance in an electrical circuit. The units are voltage is represented with a V, we can see it here. Resistance is with the omega letter, and electric current with amps. And here we have the electric current and resistance. Here we can see a little table where we have all of the formulas that we can use to when we have the known values, when you just have two known values to get all these answers: the power, current, voltage, and resistance. So the problem says, what is the resistance of the filament of a standard 60 watts light bulb? So we know that the standard household voltage is is 120 watts. This changes in between countries. Here we use that in Mexico and USA, but in other countries they can have more or less, depends on the country. So we have that the formula is P equals V times E. That P stands for power, V stands for voltage, and I stands for electric current. So we are looking for the I. So we are gonna clear that formula, making it I equals P over V. We replace the values with I equals 60 watts. That is here, it's the null value, and the standard household voltage, that is, I'm sorry, this is volts, not watts. We make the operation and we have that electric current is 0.5 amps, that is stand by the A. Then that we have this value, we can use the formula I equals V divided by R. That R is the resistance. Then we clear that out because we want to look for the R, so we have that R equals V over I. Now we replace the values. R is equal to 120 volts divided by 0.5 amps, 0.5 amps. We make the operation and we have that R, that resistance is 240, and it's represented with the omega symbol, so we are going to put it there. This is our final answer, 200 of resistance. Now we go for the Snell's law. When light travels from one medium to another, it generally bends, like we can see here, or refracts. The law of refraction is also known as the Snell's law, and gives us a way to predicting the amount of bend. The refraction involves the angles that the incident ray and the refracted ray make with the normal to the surface at the point of refraction. The refraction depends on the media through which the light rays are traveling. And we have the formula of the Snell's law. We have that N1 or Ni that stands for the index of refraction of the material. The Nr, that is N2, is index of refraction of the refracted medium. The angle 1 or angle I, angle of the incident, and angle R, that is the angle 2, angle of refraction. So our problem says a ray of light is in air approaching the boundary with a layer crown glass at the angle of 42.0 degrees. Determine the angle of refraction of the light ray upon entry the crown glass and upon leaving the crown glass. We have a little picture that shows us the problem. We have the boundary number 1 and the knowns, that is Ni1 and R is equal to 1.52, and the angle I, the angle of incidence, is 42 degrees. Now the boundary 2, that is this one, has the Ni equal to 1.52 and the Nr just 1. The unknowns are the angles R of the two boundaries. So we know that the formula is Ni sine times sine of the angle I is equal to R times sine of the angle R. So we first replace all of the values, that is Ni, that is this. We're gonna first do the boundary one. So we have that the Ni is 1 times the sinus of the 42 degrees, that is the angle that is they give us there, and that is equal to 1.52 times sine of the angle R we multiply these two values and gives us that 1 times the sine of 42 is 0.669. Now we pass this dividing, because in this side is multiplying, so on the other side would be dividing. So we make the operation that is divided by 1.52, that is 0.4402, and the formula will be sine of the angle equals 0.4402. But as we can see, we still have the sine of the angle, so we want to get rid of that. So we pass it to the other side as sine 2 minus 1 times 0.4402. So that gives us as the result that the angle R is we just multiply the sine and the amount, and it will give us 26.1 degrees. That will be our answer. This is the angle of the boundary 1. So the boundary 2 number 2 we're gonna use the same formula. So we're gonna replace the values. That is 1.52 times sine of the angle that is here of the boundary 1, that we already get it. 0.1 degrees, and is equal to 1 times the sine of the angle R. We multiply these two, and it's 0.6691, and we pass this dividing, so 0.6691 divided by 1 is just the same, so it will be sine of the angle R and it will be the same as here. We're wanna get rid of the sign, so it passes to the other side by like a sign to the -1 times 0.6691 equals to the then we do the multiplication, and we have that the angle R is 42.0 degrees, and that will be our final answers and their unknowns. Lenses can be thought of a series of tiny refraction prisms, each of which reflects light to produce their own image. When these prisms act together, they produce a bright image focused at a point. We can see that there are two types of lenses, that are the converging lenses and the divergent, and we can see the difference here. There is the little curve in here, and his looks different. We have two equations for this type of problems, and this is called the lens equation. F stands for focal, D for distance, and this D is for the distance of the image, and this is the magnification equation. The M is for magnification, H is for height of the image and height, and D is for the distance of the image and for the distance. We can see how the light goes through the lenses, like how different it is. So we have the problem that is a 4.00 centimeters tall light bulb is placed at a distance of 35.5 centimeters from a diverging lens having a focal length of -12.2 centimeters. Determine the image distance and the image size. So we have the formula. Well, first we have the knowns. That is the height, that is this is 4 centimeters. The distance, that is this one, is 35.5 centimeters, and the focal length, that is -12.2 centimeters, and the unknown, that is what we are looking for. We have the formula is 1 over f as our focal, equals to 1 d0 and 1 over the I. This is our formula, and first we're going to replace the values. So it's 1 over minus 12.2 centimeters. That is, it is equal to 1 over 35.5 centimeters, and plus 1 di, that is what they're looking for. So we do the operation on each of the sides, that is 1 divided by 12, and that is equal to minus 0.0820 centimeters, to the -1, and that is equal to the division of 1 over 35.5, that it is 0.0282 centimeters, and at the same is -1, and then plus the I. Then we pass this one to this side, and it gives us minus 0.110 centimeters to the -1 equals to 1D. And then we have that we just do this operation to elevate it to the -1, and since it's dividing 1, it will be the same, so we have that the I is 9.08 centimeters. That is the distance of the image. And now for the height, we are going to use the formula that is HI over H0, and equals to DI over D0. We replace the values, and while we do that, we pass this H to this side, so we can get HI is equal to -4, that is the H in here, because we pass it to the other side, multiplying the division of -9.08 centimeters divided by 35.5 centimeters, and that operation gives us the result that is 1.02 centimeters. This will be our final answer. And now we finish. We have the distance of the image and the height. Mirrors. This is the last subject. So if a ray of light could be observed approaching a reflecting of a flat mirror, then the behavior of the light as it reflects would follow a predictable law known as the law of refraction, same as lenses. So we can see little examples of the refraction. We can see the object reflecting in the mirror, that this is the incident ray and this is the reflected ray. As the lenses, there are two types. There is the concave mirror and the convex mirror. We can see the difference of the curves, and here is the more detailed image. This is the convex. Then we can see the image is formed on the other side, and the concave mirror that is in front. The image is in front. The formulas are the same as lenses that we explained previously, and we have a little rule of the science that is very important here. And we have this problem. It's kind of like the other problem. It says 4 centimeter type bulb is placed at a distance of 45.7 centimeter from a concave mirror having a focal length of 15.2 centimeters. Determine the image distance and the image size. We have the nose, that is the height, that is 4 centimeters, distance 35.5, and the focal length minus 12.2. And we have the nodes that are the ones we're looking for. So the formula is 1 over f equals to 1 over this 0 over di. So we replace the values. 1 over 15.2 centimeters. Then 1 over 45.7 centimeters plus di. As the other problem, we do the operations and we pass the result that is in here, that is the result passes to the other side, and we end up with 0.0439 centimeters to the minus 1 equals to 1 over di. And as the same, we just do this, we elevate it to the minus 1, and since it just divided 1, it will be the same result. So we have that dy is 22.8 centimeters. Then on the other equation, we have the height equal to minus di d0. So we replace the values. Over 4 centimeters equals minus 22.0 centimeters over 45.7 centimeters. The di is what we got here, so we just do the math and we pass the 4 centimeters to the other side like we did in the problem, and this will be minus 4 centimeters times the division of 22. Since the sign here is minus, is at the beginning, so this is at the beginning and this one don't have the sign anymore. Times 45.7 centimeters. This is minus 1.99 centimeters as our final result. And we have the distance of the image and the image size.